Assalamu alaikum. Welcome everyone
وعليكم السلام.
in the new semester. I hope all the best for all of you. Okay, this semester we have Discrete Mathematics course. It's an easy course. Hopefully you will feel this also, that it's an easy course, and hope to have fun during this course. However, it's an easy course, but of course you need to study, to do exercises from the book and so on. First of all, I would like to mention some issues, introduce the course, then we can start with the first subject. First issue, the attendance. Maybe you have experience from last semester about the attendance problem. Here also, we will take the attendance. I will give you time for asking. Don't ask questions now. Please, for everyone, don't cut me while I'm speaking. If you have a question, I will give you time for questions. Okay, anyway, about the attendance, it's compulsory also during this course. Actually, during all the courses. So if you absent for, I think, about 4 weeks or 5 weeks, you cannot attend the exam. How we will take the attendance? It's automatically from Microsoft Teams. We will get file for attendance, and we will import this file to e-Ukluma, the attendance system. So I will not share any code with you. You don't need to register. Just attending here in Microsoft Teams. This means you will be registered in the attendance system, but you must attend this course using your student email, student account. If you use your student email, student account to join this course and other courses, you will be counted in the register system. Okay, attendance system, sorry. Okay, this first issue, the attendance. Second issue, of course, we have our Telegram group. Okay, I will share the code with you, and I will share everyone. Don't join it now because I don't need many notification. This is the code I'm sharing now through the chat. Okay, here. And also you can read the code for our Telegram group. Don't join it now. In the break time, you can join, okay? Because I don't need all this notification now. When you join our Telegram group, of course, I think many of you already take courses with me before that. We depend too much on Telegram group because lecture note, everything will be through our Telegram group. Okay, so you have to join the Telegram group. Let me share the screen. So we have the Telegram group. You have to join this Telegram group. I said not now, just wait for the break time, then you can join. I'm speaking with myself, yes. Anyone will join it during the course now, I will kick him out from the Telegram group. Don't join now, okay? Wait until the break time, then you can join. Another issue, in the Telegram group, you will find here a link for my YouTube channel. Subscribe in it, because in this channel, I will upload all the lecture notes from the previous year, okay? I will upload all the lecture notes from the previous year, so you can watch the lecture note before, you can watch the video for the lecture note before coming to the lecture or after for review. It's up to you. So you have to subscribe, because always I will add videos when I have time. Maybe I will have 1 video, 2 videos, 3 videos. I have actually all the videos, but you know, it will take some time to upload the videos. I will try to upload most of them, okay, as soon as possible. Okay, this second issue, our Telegram group and our channel in the YouTube. About this course, let's see this course. This syllabus. Okay. Okay, this is a syllabus. We have 2 subjects. First of all, we will speak about the propositional. Okay, it's part from the logic, so we will speak about logic, propositional logic, logical equivalence, some laws for logic, and some inference rules for logic. Okay, as you know, logic is important part from computer science and computer engineering when we speak about softwares, artificial intelligence, and so on. Then we will speak about mathematical proof, mathematical induction, its type of mathematical proof. Then counting methods like product, Cartesian product, like eigenhole, like permutation, combination, and so on. Then we will speak about series and recurrence relations to solve and solving series, like in factorial, like all these types of series. We will take how to solve it. Then another important subject, which is graph theory. We will speak about the graph theory. It's very important part from computer science, also graph theory and trees. And last subject will be cryptology. Okay, encrypting and decrypting the data. We will speak about all the methods about encrypting and decrypting the data. This is about the subject. As you can see, it's also subject related to computer engineering and computer science. That's why it's discrete mathematics. It's not about one subject from from mathematics, it's discrete. Some subjects not really have connection, but it's have connection to your major, which is computer engineer. So we need all this. If we want to compare with, as you ask, with differential equations, of course, this is much easier than differential equation. We don't have that complicated subjects during this course, but also you need to solve as much exercises as possible. About the exercises, we have a book. I already shared the book with you, okay? This book. Let me show you the book. Okay, someone will ask, we will depend on this book mainly. Look, I will give you lecture notes. Lecture notes will be enough to understand the subjects, but you need this book, you need it to do exercises. And I will give you exercises numbers from here, okay? For example, if we go to any subject, you will find exercises after this subject, like this. I will give you from this exercises, I will give you, or from this questions, I will give you some exercises to solve it. If you need to solve more, also it's better for you. But I will mention some exercises for you to solve it from the book. So it's like any mathematical book that have some exercises and you need to solve the exercises. Okay. About the marks. We have in this semester, we will have midterm, of course, for 40%. We will have 1 or 2 quizzes. To do the quizzes, you must know the OAS system. Okay, we know the OAS system. You must know this system. You must log into this system and know this system because our quizzes will be on this system. Okay, later I will tell you when we have a quiz, then you need to log into this system here. They describe for you how to log in. Okay. So if we have a quiz, you will answer this quiz here. Okay. Last issue here, it's about the online. Don't depend that all the semester will be online. Almost. We will take this, or the university will be online, I think, until April. During April, there is a strong news that we will return to face-to-face lectures. So almost in April, we will return to face-to-face lectures. So almost your midterm exam and final exam will be face-to-face. Okay. These are issues. So we can start if you don't have any questions. Okay, if anyone have a question before we start with the first lecture note. Okay, about the break, we will usually take one break, 10 minutes, in the middle of the time. So we start around 9:40, okay, until 10:50. Then we will take 10 minutes, inshallah, until 10. Then 10 minutes break. Then from 10 until 12, we will continue. I told you the attendance. I will show you how the attendance will be taken. Okay, when you attend here, you see, using our or your university email. After I finish, I will find the attendance report. I will show you in another course. For example, here. Okay, there is attendance report. So when you attend directly, you will be in this attendance report. Then I will take this attendance report to our attendance system. Okay, our attendance system, then I can directly just import it to the system and it will register the attendance. For example, this yesterday attendance. As you can see, I register the attendance here. Here you can see the students. I don't know why this is small, but you can see that the attendance for the students registered here. How? As I told you, from this file, after I finish and I end this meeting, directly here the system will take your attendance. So you have to attend until the end of the lecture also. Okay, don't leave, because also this will be registered how long you attend. Okay, so that's all. Let's start our lecture, first lecture. I will turn off my camera. Okay, I will share again. I feel there's okay, anyway, as I mentioned, our lecture is or our subject discrete mathematics. First lecture will be about propositional logic. Okay, so our first subject, it's a very simple subject. We will not take too much information today. It's about propositional logic. Of course, I will give you this code during the break. I will leave this code for you to attend the Telegram, not now. Okay. So I don't need this one. Okay. So why to study discrete mathematics? Why we are in computer engineering study discrete mathematics? First of all, what is discrete mathematics? Actually, it's type of mathematics that have discrete subject, not like calculus, okay, that speak about or deal with continuous changes, okay. So in discrete mathematics, we will take some mathematical bases and some mathematical subjects that important for computation and important for computers. Like logic, it's important subject in the computer, like graphics. Okay, we don't speak about the graphic design, a graph and the graph theory. Many things in computer science depend on graph, like the design of the computer networks and so on. So this mathematical basis, it's the backbone of computer science. Okay, it's important subjects for computer science and computer engineering. For example, also cryptography and encryption, and some parts that important for problem solving, like logic and so on. Okay, so as I mentioned, I prefer during our course, don't open your mic except when I allow you. This means if you have a question and you want to speak, raise your hand first, then I will let you speak. Don't open your mic and speak before I allow you, okay? Because we cannot open it for everyone. Okay, so during this semester first subject, we will speak about the propositional logic, then the inference rule or rules of inferencing. This means inference one logic from other logics. Okay, then we will speak about mathematical proof, how to prove some statements. Okay, it's important in computer, this mathematical proof, so we can convert anything to mathematical relation and make mathematical proof. And one of the most important mathematical proof, which is mathematical induction. Then we will speak about counting or numbering theories, like combination and permutation, Cartesian product, and so on. Then we will speak about series and how to solve series or relations. Okay, so we will speak about recurrence relations, then graph theory and trees, and last subject will be cryptology, encrypting and decrypting the data. Okay, let's start with the first subject, which is propositional logic. What's the meaning of a proposition? Actually, proposition, it's a declarative sentence or a sentence that give you a fact, declare a fact. Okay, Ahmad is tall. Omar is fast, and so on. So it gives you a fact. This fact may be true, may be false. So any sentence, declarative sentence, that clearly is the true or false, but not both. For example, the questions. Okay, how are you? Is it true or false? Is it fact? No, it's not fact. So it's not a proposition. So what is a proposition? A proposition, it's a declarative sentence that give you a fact, declare a fact. This fact could be true, could be false. Like if I said, Karabuk is the capital of Turkey. It's a proposition, but it's false. Okay, it gives me false, so it's a proposition. Okay, so in the propositional logic, to mention that specific proposition true or false, we can use T capital for true and F capital for false. Okay, let's let us check this proposition. Which one a proposition, which one not a proposition. Okay, so first one, Ankara is the capital of Turkey. Is it a proposition or not? To know it's a proposition or not, if you can mention that it's true, or if you can mention it's false, then it's a proposition. So if it's fact, a true fact or false fact, it's a proposition. So as we can see here, this give me information, give me fact. So it's a proposition. Read this carefully. Is it a proposition? You can write your answer in the chat, yes or no. Okay, so yeah, it's not a proposition, this one. Okay, 1 plus 2 equal 3. Is it a proposition? Yes. Why? Because it gives us a fact. Why, Yusuf, you said no? It's a proposition. It's give us a fact. 1 plus 2 equal 3. Even if I said 1 plus 2 equal 5, it's a proposition. Yes, this fact false, but it's a proposition because I know that it's false. So this one is a proposition. X plus 1 equal 2. Is it a proposition? One or X plus 1 equal 2. Is it a proposition? Yes or no? No, it's not a proposition. To know it's a proposition or not, you have to ask yourself, this statement, is true or false? You can answer it. There is one student who said, yes, it's a proposition. Answer me, is it true or false, this statement? X plus 1 equal 2. Is it true? I don't know. If X equal 1, it's true. But maybe it's false. If X equal 2 or 3, it's false. So I don't know, is it true or false? That's why it's not a proposition. Okay. What time is it? Also, it's not a fact. I did not give you any fact that it's true or false. So this one also not a proposition. Okay, so how to know the proposition? If it's give you fact, this fact is true or false, then it's a proposition. Okay, now let's speak about the propositional logic. Propositional logic, okay, propositional logic, it's the area of logic that deals with proposition. You can see later we can connect between more than one proposition and try to prove this proposition, is it true or false, and so on. This is a very important part from artificial intelligence. Many parts from AI, from artificial intelligence, use the logic. Okay, even some language like Lisp and so on, this language that used to build some expert systems use the logic. Same way like what we will take in discrete mathematics. So, propositional logic, it's the logic that deals with a proposition. We will use to represent any proposition, we will use some variables like P, Q, R, S. If in one statement we need more proposition, we can use K, L, and so on. But almost we use this P, Q, R, S for the proposition. For example, we have this proposition P, then as you can see here, 2 dots, then this proposition. Why we need this? We need this because when we will use mathematical proof and we have many mathematical statements, and you will see we have many steps. We cannot every time repeat this the full sentence, especially if it's big, the proposition. So after that, okay, we define, as you can see, we define the variable for the proposition. After that, we can use now this P instead of the proposition, like any variable, yes? So we use this way to give short name or only one variable, one character to identify the proposition. Okay, this proposition, as I told, could be true. You have to use T capital, or false. You have to use F capital, because sometimes we use T small as a name for some proposition, okay? To connect between propositions and make some calculations between propositions, we usually use logical operators. As I mentioned, a proposition, it's a fact that gives you true or false. As you know from programming and so on, we can connect between true and false using and, or, not, and so on. So this logical operators, we can use it to get a new proposition from one or more proposition. Some operator only take one proposition, like not. Ahmad tall, Ahmad not tall, okay? Or more than one proposition, get a new proposition from more than one proposition, like and Ahmad tall and fat, for example. Okay, so we have two propositions connect using and. Also, we have or logical operator. Okay, so Ahmad, sorry if there is Ahmad here. Yes, it's not you. Okay, Ahmad, tall or smart. Okay, so two proposition, Ahmad tall, Ahmad smart, connect between them, Ahmad tall or smart. XOR, okay, we will take it later, and this one not. So this Boolean logic, and also we have implication. Implication means if statement, yes? So this one implies, and this one bidirectional, two direct implication. Okay, we will take all of this. Okay, we will start with the first logical operator, which is negation, or the negative of the proposition. Okay, so it has this symbol. This means not. Okay, not the negative of the proposition. Okay, so if we have P, this not P. Not P means P is false. So if the original P is false, false of the false is true. Yes? And false of the true is false. So if it false become true, if it true become false. Example, Ahmad also. Ahmad does not love our course. Yes? If we make it not, this means Ahmad love our course. So this is the meaning of not. From not, you get a new proposition that the opposite of the original proposition. This is a unary operator. What's the meaning of unary? It's come from one, yes? So means it's take only one proposition and transfer it to the negative. Okay, usually we use the truth table to identify or to represent the logical operator, and also to prove some propositional logic or some propositional statement. When you have more than one proposition and you want to prove it, is it true or false, you can use the truth table. What's the truth table? The truth table, you take all the propositions and give all the possibilities. Okay, I will give you some information about the truth table, then we return to this one. Okay. Not you, Ahmed. This is another Ahmed. You are Ahmed or Ahmed. That one, Ahmed. Okay. Okay. Let me just I will save it here. Okay, so truth table like this. Usually, if you have one proposition, okay. If you have one proposition, how many possibilities you have? You will have only, if you have one proposition P, you have two possibilities. Let me just make it in the middle. Okay, so we have two possibilities. What's the possibilities for any proposition? True or false? Yes. So if we have one proposition, we have two possibilities, true or false. If we have two proposition, let me just copy and paste here. Okay, if we have two proposition, P and Q. P small letter, always a proposition small letter, we write it. Okay, how many possibilities we have? Maybe P is true and Q is true. Maybe P is true and Q is false. And the other possibility, P is false, Q is true, and P is false, Q is false. This all the possibilities. So, as you can see, when we have two, so how many possibilities we have? 2 to power 2. Yes, so it's like this. Okay, 2 to power n. N means how many proposition? Okay, so if we have two proposition means 2 to power 2, which is 4 possibilities we have. Okay, this is a truth table. Let's try. Okay, let me just. If we have more. So I will insert another one. If we have proposition R. How many possibilities now we have? We have this 2 to power 3, which is 8 possibilities. So the truth table now have 8 possibilities. So I need, instead of this, we need 8. How to write it? Okay, 8. You write it like this. True, true, true. This is all the possibilities here. True, true, true. 4 means here. And for F, 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 F. This about P. Now, here's the possibilities that Q is true, true, false, false. So, when you have 8, then 4 true, 4 false. Then 2 true, 2 false, 2 true, 2 false. This is the possibilities. Then 1 true, 1 false, true, false, true, false, true, false. So this all the possibilities that all of them true or PQ true but are false or true, false, true. If you check, there's no two lines same. So this all the possibilities. Okay, if you have 4, same issue. It's easy. I will not. Okay. Even if you have 4. 4, what's the meaning of 4 proposition? 4 proposition, this means 2 to power 4. This is our truth table, which is how much? It's 16. So if it's 16, I will not fill the whole table, but I will show you how to fill it. You need 16. So you will fill it like this. That's, mhm, 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 mhm. Let me just delete this part. Okay. So you will have another column here, P, Q, R, S. So you need to fill here 8 true, why it's not okay. Make it in the center. So true, 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 true. You should fill 8. 1, 2, 3, 4, 5, 6, 7, 8. Then the remain false. Okay. And here 4 false. 4 true, 4 false. Here 2 true, 2 false, and so on. Here 1 true, 1 false, 1 true, 1 false, and so on. You can fill it like this. So this is the way of the truth table. Okay. Okay, so let's continue now. Okay, so we use the truth table to represent the proposition and also to get a result and make a logical proof also for some proposition. So the truth table lists all the possible combination for the values for any proposition. Example, this is the truth table for the negation or the negative. We have one proposition, P, and the negative of the proposition, not P. So this proposition P could be true or false. The negative for it, false or true. If it's true, become false. If it's false, become true. Okay. Conjunction. Conjunction, or we name it and. You know and. And it's connect between two operators or two propositions. So we called it binary operators. Binary operator. So conjunction, we give it this symbol. So use this symbol for conjunction or and. Okay, this symbol for and. Okay, this and operator or conjunction. Okay. We used it to connect between two propositions, and this conjunction or this and is true only if and only if P and Q is true. So if both sides are true, the result of this operator will be true. If any of the sides not true, the result will be false. So to make the truth table for this conjunction, for this and, we have two sides, P and Q. So P, Q, what all the possibilities? P, which is true, true, false, false. Q, which is true, false, true, false. So when both sides are true, the result for the AND operator will be true. If any side is false, like this, then the result will be false. So, AND give you true only if both side is true. If and only if both side is true, it will give you true. Disjunction, we called it OR. Yes, it's also a binary operator that connect between, binary means two, yes, operator. Why? It's connect between two proposition, and we use this symbol for or disjunction. We use this operator. So when the result will be true, if any side is true, okay, if P or Q is true or both of them true, then the result is true. So shortly, if you see any side true, the result will be true. Example for or statement, Alice is smart or honest. I want to write it as a disjunction. To write it, we can consider Alice is smart as P. Alice is honest or honest as Q. So we can write it P or Q. This is a truth table for the disjunction. This all the possibilities for P and all the possibilities for Q. True, true, false, false, true, false, true, false. So if any side is true, the result will be true. If both side is false, the result will be false. So this is a disjunction. Implication or conditional statement. One of the important statement, which is the conditional. Why we called it conditional statement? Because actually it's like if statement. It's like if statement. And what symbol we use? We use this arrow, okay? So if you said P implies, this is the implication, implies Q, it's same like you said, if P, this means if P true, then Q is it true. So we consider P our hypothesis. We imagine, we assume that P is true, then we conclude that Q will be true. That's why we call this first part as the hypothesis, first part of the implication. Second part, we name it the conclusion. the result of this hypothesis. So, take this example. You have to focus on the implication truth table, okay? If this car costs less than 10,000, then Ali will buy it. Okay, so we want to write it as implication. If this car, so first fact, this car costs less than 10,000, this P. Then Ali will buy it. Ali will buy it. It's another truth or another fact, so it's Q. So we can write it that P implies Q. Okay, the question here, this implication, when it will be true? You imagine we have all the possibilities. P, Q, and P implies a Q. What all the possibilities? True, true, false, false, true, false, true, false. Who can get this one? Okay, first one. Is it true or false? Here. And why? True, of course, it's clear. It's the most clear one. It's true. Because if the car costs less than, if the car costs less than 10,000, Ali will buy it. So the sentence itself is true. Okay, second one. Is it true or false? P is true, Q is false. This will give me true or false. It will give me false. Why it will give me false? Because I give you this fact. I told you if the car costs less than 10,000, Ali will buy it. But here it's cost less than 10,000 and Q, which is Ali will buy it, it's false, so Ali will not buy it. It's the opposite of our implication. So this one is false. Okay. P is false, Q is true. Is it false or true? Okay, let me ask you. If the car more than 10,000, Ali will buy it or will not buy it? We don't know. We don't know. It's not mentioned here. If the car more than 10,000, we don't know if Ali will buy it or will not buy it. That's why if P is false, we don't know if Q is true or false. We don't know Ali will buy the car or not. That's why if P, the first part, is false, always the result will be true. The result of the implication, because we don't know this statement false totally, all the statement. We don't know if it false or true. If we know only first part is false. So there is nothing telling me that Ali will buy the car or not buy the car in this statement. So this statement is still true. So the implication, if we have two sides true, the implication is true. If we have P as true, Q as false, the implication false. Always if we have P as false, the implication always true. So only if P is true and Q is false, the implication will give me false. So if P is false, the implication always true. If first part is false, the implication is always true. And if both sides are true, the implication of course is true. Only this, the possibilities for the false of the implication. If first part true and second part false, because this makes the implication incorrect. This will not make the implication false. This one will not make the implication false, and this one, of course, makes the implication true. Okay, the only one makes the implication false, this one, because we said first part true, but it gives us second part as false, and this is the opposite of our implication. Okay, so this is the issue for implication. Implication always true except if first part true give me false in the second part. In this case only we have false. Okay. Actually, implication, it's same as if you take not P or Q. So implication and this one, not P or Q, logically equivalence. What's the meaning of logically equivalence? Mean they give us same truth table. They give us same result in the truth table. They are equivalent. So implication and with not P or Q, it's logically equivalent. It's important to know the logically equivalent because it's part from the proof. Later you will see that we use it for proving some logical statement. Okay, so let's take this example. If I am elected, then I will lower the tax. Okay. If I am elected, then I will lower the tax. Let's take it. If I am elected, this P, then I will lower the tax. Lower the tax, it's a Q. So we have implication. P implies Q. Which of this statement will be true? Which will be false? We have four statements. 1, 2, 3, 4. Some statements will be true, some will be false. Which one? Depending on the implication. Look to the implication and try to Find which one of this implication true, which one false. Okay, so there's one correct answer from your answers. Okay, so we have actually one false only, and other will be true. If you look here, P implies Q. It so this P, this Q, it will be only false if P true and Q false. This will give me false. Yes. So elected, this is true. Lower tax, I will lower tax. This is true. True implies true. It's true. Elected, not lower tax. This means true implies false. This give me false. True implies false. Give me false. Not elected. Maybe the other one who elected will lower the tax. I don't know. Yes. So not elected. This means false. Give you true. False. Give you true. Yes. If always if P false, the result will be true of the implication. So not elected also false. Directly the result will be true. Doesn't matter this part false or true. If the first part false, then directly the result of implication is true. Okay, we can take around 15 minutes break. Okay, or 13 minutes to be precise here. 13 minutes. So we will return at 11 and continue. Okay, don't leave the meeting because of the attendance. You can only take the break until 11 anywhere. Just keep yourself in the meeting and do whatever you want to do during this 12 minutes now. Okay, see you after the break. Assalamu alaikum again.
Yes, sir, we're here. Well, I'm here.
Yes, yes, Ahmed, you are here. I will give more examples about you.
I'm glad I'm turning to your mascot, sir.
Okay, so we already completed lecture note 1. I will start with lecture note 2. We will take just a small part from lecture note 2. By the way, I already shared lecture note 1 and 2 with you. Also, I shared the book again. I mentioned it. Okay, so how many one around? Just raise your hand if you are around. I want to count how many one around. Okay. 9, 19, 18, 20, 23. Okay, good number. Okay, so. Okay, just let's continue. Okay, so lecture note 2, actually, it's also about propositional logic. So it's, as I mentioned for you, it's a simple subject, first subject, which is propositional logic, but there we have a lot of rules that you have to memorize it in the propositional logic. Later, when you see next lecture, you will find many rules that you need to memorize it. Okay, let's continue with the terminology. So, I forget to share the link. I don't know if some of you did not attend yet our Telegram group, but I forget to share the link during the break time. So I will just okay, I will just share it now in our chat. Okay, so continue. We have many ways, many statements to mention the implication. So you have to know it from English statement, because you could have some statements that you need to know from it the implication or other operation, and or blah blah. It's simple. Implication have many ways to express it or to describe it. Okay, so P implies a Q. It can be written in many ways. For example, if P, then Q. If P, then Q. This is the main statement actually for the implication. Other statement. Okay, I will give you around 10 minutes after we finish. You can join the Telegram group. Now just focus here, don't join the Telegram group now. At the end of the lecture, I will give you around 10 minutes. I will keep this open and I will give you time to join the group, okay? Another statement for the implication, a Q if P, a Q if P. This means Q is true if P is true. Q is correct if P is correct. This is the meaning of the implication. It's not related to the truth table, do not connect it, okay? This means if I give you P is true, if I give you Q is true, P is true, or the opposite, sorry. Okay, P only if Q. P only if Q. It's many ways only to write the same implication. Okay, P implies Q. This is the direct one. This one and this one, it's the direct one. If P then Q, P implies Q. P is sufficient for Q. P is sufficient for Q. Now the opposite. Q is necessary for P. And the other statement also, Q follows from P. So we can get the Q from P. All these statements means implication, but you have to know which one implies which one. So as you can see, all of them P mentioned first, except in 3 cases. This one, this one, this one. Okay. So Q if P means P implies a Q. This the only cases that Q mentioned before P. Q is necessary for B means P implies Q. Q follows from P means P implies Q. So all these statements means P implies Q. Okay. Later we will take how to translate from the English language to the operations, propositional logic like this, and the opposite also. Okay, this example, P proposition, Alice is smart. Q proposition, Alice is honest or honest. Okay, honest. P implies Q means P, which is Alice is smart, implies Q. We can mention it in many ways. For example, if P then Q means if Alice is smart, then Alice is honest. Okay, we can use sufficient. Sufficient, P is sufficient for Q, means that Alice is smart, sufficient for Alice to be honest. So P is sufficient for Q. Alice is honest if Alice is smart. Here we use a Q first. So Q if P. So Alice is honest, which is Q. if Alice is smart. So Alice is honest if Alice is smart. Okay, let's see this one. Q implies T. That Alice is smart is necessary. As you can see here, is necessary. You start with the Q, then you get P. Alice is smart, this P. Alice is honest, this Q. So you start with the second side. Look, what's the implication I said? Q implies P. So you start with this part. So you will start with P when you said is necessary to get the Q. So Alice is smart is necessary for Alice to be honest. Okay, Alice is honest only if it's take what? It's take first side, which is a Q here, first side, and second side, which is P. Here, okay, it's make you confused. Why? Because the implication here written the opposite like this implication. Okay, so don't fix your mind in P and Q. This left side and this right side. So you can remove here P and Q and use in this rule, you can use right side and left side. So this right side, this left side, here right side P, here right side Q. So I know it's about language, maybe it will let you little bit confused, but with a training, you will understand it. Okay, anyway, we don't focus too much about implication language, okay? You will see later that we will take the rules directly without focus too much about those language. So almost this part, okay, we don't use it too much. We use usually if P then Q, P only if Q, or the most simple one, which is P implies a Q. So this one's the most used ones, and sometimes this one, and all of them direct from P to a Q. Okay, so bidirectional, bi means two, yes? Bidirectional implication means implications that have two ways. Actually, you can, if we said P bidirectional Q, this means P implies Q and a Q implies P. So this is the meaning of bidirectional. P implies Q and the Q implies P. It have both, okay? So this is a bidirectional operator. When it will be true, it's easy. P is true if and only, this is the meaning of bidirectional. P is true if and only if Q is true. So it's like, you know, no one will help you except me. If I'm exist, I will accept you. No one else will help you. So if I'm not exist, no one will help you. So this bidirectional. Okay, so P is true if and only if Q is true. So let's take the truth table. If P is true and Q is true, then this statement is true. Also the opposite. If P is false, if and only if Q is false. This also keeps a bidirectional true. So if both true or both false, the result will be true. If any side false, the result will be false. Okay, if they are similar, same, the result of the bidirectional implication is true. If they are different, P and Q proposition different, then the result false. Why? Because as I told you, it's two direction. P bidirection implication Q means P implies Q, Q implies P. So if both true or both false, this statement, the whole statement, the bidirection will be true. Because true implies true and false implies false. Okay, so both true, the result is true. Both false, the result is true. The two proposition different, the result will be false. This is a bidirectional. I think last one I will give the XOR and we will stop here. So we still have only two slides and we will finish. Exclusive OR, XOR. Maybe you heard about XOR. It's very famous in the computer. Okay, and it's used actually in the signal and so on. And in the circle, also computer circuits, you have OR, you have and you have XOR. Okay, how it's work? Actually, exclusive OR or XOR, it's the negative of bidirection. So as you can see here, bidirection, when they are same, the result is true. XOR the opposite. So XOR actually it's a logical equivalent for not by B bidirectional Q. It's the opposite for this. It's the negative for this. So this means if P and Q same, the result of the XOR false. If they are different, the result of XOR will be true. So the truth table of XOR, it's like this. If PQ same, the result false. If P and Q different, as you can see here, the result is a true of the XOR. Okay, last one, the precedence of operators means the priority. If you have many operators, what's the priority? First of all, if you have many operators in the same statement like this, we have not, we have or. Like this statement, we have, we have not and, we have and, we have implication in the same statement. So which one you will use first? First priority for not. So in this statement, you have to calculate not, then make and. Okay, so not and or. So if you have or and, first you need to calculate and, then you can calculate or. Then implication, then bidirection implication. So this is a priority. If you have more than one operator, you have to take it in this direction, starting from and or not and or implication, bidirection implication. Okay, so we have and, we have bidirection, then you have to calculate and, this first priority, then bidirection, it's a second priority. Enough for today. I don't want to give all this lecture note. Okay, I think it's enough for today. We can continue, inshallah, next week with this lecture note. We still have the logical formula, take the logical formula from the English sentence. When you have English sentence, how to write the logical formula, and the opposite, how to translate the logical formula to English sentence. Okay. After that, we will take important subject which is tautology and logical equivalent. So usually in the exam, we ask you to prove some statements, is it a tautology or not, and to prove the logical equivalence. We have many ways. There is rules and there is the truth table. First, we will learn you how to use the truth table for the tautology and logical equivalent. Then after that, we will give you some rules also. And usually if we ask you some questions, we will tell you to use the truth table or the laws, like De Morgan law and other laws. Okay, and we will take more examples. All this and some law like De Morgan and distributivity and so on. Inshallah, all this. Of course, you have a lot of laws to memorize. We will give this laws, inshallah, next week. Okay, so that's all. Before we finish, if you have any question, this is the link. You can start using it. I will keep this open for another 10 minutes, okay, for you to join the group. Any question? If you don't have any question, let me just finish here. Okay, so I will stop the recording. And sorry, anyone have question?
Excuse me, teacher. I want to ask you about this subject. How many teachers give this subject in the university, or just you? And the question
I give for the English sections, and there's Dr. Burhan give for the Turkish sections.
Just to,
and the exam, yes, and the exam will be common exam, will be shared.
Thank you.
Okay, any other questions? Okay, so see you inshallah next week. You can leave the meeting if you don't have anything. I will keep it open for a few minutes also for the recording before I end this meeting.